Good morning, everybody. We have started the last lecture, that is chapter feedback amplifier. So what do you mean by feedback amplifier? That we have first seen, and that we have to be studied with startup of the feedback amplifier, why it is used, what are their application, and the why we need of the feedback in case of your amplifier. That is important thing, and one of the important condition related to it is that different application of feedback, right? Means where it is used, right? That we have to be studied in this chapter, right? So for that purpose, we have to be seen the concept of feedback. What do you mean by concept? See, it is same as like as normal feedback. Feedback is nothing but a some part of output is again applied to the input. It is nothing but a feedback. So which type of and where it is used, that are important thing, right? So see, we just discussing the feedback with respect to your amplifier. We know that we have seen that different type of the amplifier. We know that there are three configuration of your transistor, that is common emitter, common base, and common collector, right? These are the three configuration which are used for the purpose of construction of the amplifier. Each and every, see, common emitter or common base or common collector, it has its advantages and disadvantages, right? So normally for the purpose of amplifier, we have to be normally preferred the common emitter configuration. See, in case of your common emitter amplifier, see, whatever the input applied, its 180-degree phase shifted output is coming across your output of your amplifier, right? See, whatever applied, exactly opposite is coming across output with amplified gain. So how it is acceptable? See, for that purpose we have to be use another stage. See, another stage of this same common emitter amplifier, which causes we got the output as we have applied, right, with increasing gain, right? That's why we have to be use the common emitter amplifier. And the one of the important thing related to the common emitter configuration is that when we have to use the common emitter configuration for the purpose of amplification, it gives the pure amplified signal and no no instability of the wave whatever applied, right? Means there should not be variation whatever the signal applied across it. So that's why we have to be prefer the common emitter amplifier for the amplification or the for the audio amplifier, right? We know that application in many function we have to use the amplifier with the amplifier sorry, we have to be use the mic with amplifier, right? This is the application of the normally audio amplifier which is used in a common emitter configuration, right? See, we have seen the concept of feedback which are related to the feedback amplifier, right? So feedback indicate that, see, this is the diagram of the feedback, right? So vacuum tube amplifier, it is nothing but any type of amplifier. We have, see, there are, when we have to be designing the transistor, that is transistor is normally designed at near about 1955, right? Before that we have to be use the vacuum tube. Vacuum tube indicate that it is same as like as your transistor, but the whatever the construction or whatever the material used for the construction of vacuum tube, that is required more, and the size of the vacuum tube is more, right? So that's why this is considered as a amplifier which should be constructed from your transistor, right? So we have applied the in case of feedback, see, consider as this is your amplifier, this is the block diagram of your amplifier, right? This block diagram of amplifier, as we have to be applied the input indicate that we know that in case of your amplifier we have applied the input that is a smallest base signal is applied as a input to the particular amplifier. Amplifier is the device which should does the amplification function, right? For that purposes, see, required signal is coming from your collector that should be drawn whatever the beta is nothing but a current gain factor of your amplifier, right? And then we have to be got the output that is a output of your amplifier, right? This is the thing with respect to amplifier only, right? We have applied the input, processing of the amplifier is done, after all we got the output. This is happen with respect to the amplifier. But see, in case of your feedback amplifier, what we have to do, we have applied the input and we got the, after all the amplifier circuit, we got the output. See, some part of output that again apply to the input, it is nothing but a feedback. Means when we have applied the input to the amplifier, it got the output, some part of output is again applied to the input. This is nothing but a feedback, right? Feedback concept is लक्षात आला का? Feedback concept काय असतो, some part of amplifier output is again applied to the input. This is nothing but a feedback. Okay, रिप्लाय दे जाओ. लक्षात आला का फीडबॅकचा कन्सेप्ट? रिवाइज करतोय आपण, लक्षात आलाय ना? बचोटे लक्षात आलाय का तुमच्या?
Yes, sir.
Okay, this will be the thing related to the feedback. See, I will tell you there are different type of feedback. See which type of feedback is in which type of the amplifier that we have seen, what are their application, that also seen in the next slide. Now see, we have seen the definition of the feedback amplifier, right? So definition of feedback amplifier indicate that normally feedback, we just see again the concept of feedback, some part of output is again applied to the input. This is nothing but a feedback. But feedback amplifier indicate that we have applied the input to the particular amplifier and output of it is coming out with respect to your amplifier. So output of amplifier is again applied to the input of amplifier. This is nothing but a feedback amplifier, right? So feedback amplifier is nothing any other thing. Means in that case only thing means the definition of feedback and definition of feedback amplifier, only thing is changed that in case of feedback part of output is again applied to the input, but in case of feedback amplifier the part of feedback amplifier output is again applied to the input of feedback amplifier. This is nothing but a definition of feedback amplifier, right? So in that case what we have to do, in case of feedback amplifier only, see, only part of output is again applied to the input. There are different type of the amplifier. If it is with respect to the in phase and output, in phase and out of phase, that we have to discuss. In phase indicate that if we have to apply the output of the amplifier it again to the input, it is in phase. In phase indicate that we apply the sine wave as an input to the amplifier, we got also output is nothing but a feedback again, it is again coming to the feedback. This also sine wave, in that case that are in phase. If it is if apply the input is C, if apply the input is sine wave and output is coming cos wave, right? See, this is the thing with respect to common emitter amplifier, only single stage of common emitter amplifier, right? We have applied the sine wave, we got the cos wave, then again it is applied as a feedback to the input, right? So input is sine wave, output is cos wave, so both are in out of phase, right? That feedback is called as that are called as negative type of feedback, right? So positive and negative feedback indicate that when the input and output indicate that feedback that are in phase indicate that we have applied the sine wave, we also feedback is coming with respect to sine wave, in that case they are in phase. When we apply the sine wave, output is again apply here as a input, it is cos wave, in that case whatever the input and whatever the output that are out of phase, this is nothing but a negative feedback, right? So both type of feedback is in case of different application of transistor, how it is used, what are their need and what it does, that we have seen in the next slide. See, now see, we have seen the types of feedback amplifier. We know that types of feedback amplifier, what it indicate that, see, when we have to be use any of the amplifier for our application, it have different type of feedback according to their need and according to their application, right? So there are basically two types of the feedback in case of your amplifier. One is positive feedback and other is negative feedback, right? So this is the, there are two diagram, one is positive feedback diagram, other is negative feedback diagram, right? So for the positive feedback, as we have seen that this is the input, this is feedback, this is your output, this whole configuration. See, this is the symbol of your amplifier, right? A indicate amplifier, right? So see, we have applied input as a sine wave to the input of your amplifier, right? Sine wave is applied as input to the amplifier. Again, see, amplifier indicate, this is the symbol of amplifier, it indicates that it does the function of amplification, right? So whatever the signal applied, same signal should be amplified. See, in case of your positive feedback, there should not be change with respect to your signal, right? Means if we have applied the sine wave, output coming also the same sine wave, right? It in a increasing size, it indicates that only, see, we have applied the sine wave, only size of this signal is increasing with respect to your output. Again, part of it is again applied to the feedback, right? Part of it again applied to the feedback as a input, right? So applied signal is sine wave, part of it also sine wave, means both signal are in a sine wave, so it indicate that positive feedback, right? So what do you mean by positive feedback? See, whatever the input applied and the part of output, it is nothing but a feedback, both are in phase. In that case, that type of feedback is called as positive feedback, right? Positive feedback, I'll tell you related to positive feedback, the concept of positive feedback usually in case of your oscillator, right? Oscillator indicate that generation of the sine wave, right? It is, see, when we have to be use the positive feedback, it increases the gain of amplifier, right? But the, if it is increases the gain of amplifier, but also it is not used in case of amplifier, because it increases the gain but it doesn't stabilizes. What it indicate, gain जरी वाढवत असला नाही तर त्यानं gain stabilize होत नाही म्हणजे समजा 10 किलोहर्ट्ज आपली गेन पाहिजे असेल तर ते कधी 11 किलोहर्ट्ज होते 9 किलोहर्ट्ज होते, अशी फ्लक्च्युएटिंग होत राहते. This is not acceptable because positive feedback causes gain should be varying, right? This will be happen. See, we have seen the concept of negative feedback. See, negative feedback, what it indicate that, see, in case of a negative feedback, we have applied the input signal. See, this is your input signal, right? This is input signal applied to the input of your amplifier, right? So this amplifier circuit does the function of amplification, right? Because it is as like as block, means it is as like as block. Internally, block indicate that it should does the function of whatever the amplifier, right? So sine wave is applied to the input of the amplifier amplified signal, right? But consider here as this type of configuration uses the common emitter amplifier. We know that whatever the input applied and whatever the output got, we know that the output of the this configuration indicator negative feedback, the output of this type of amplifier is 180-degree phase shifted. We know that output of common amplifier must be 180-degree phase shifted by your input, right? So that we have applied the sine wave, we got output as a cos wave, right? So this cos wave, again, this is nothing beta. See, here is beta, here is beta. It indicates that feedback factor, right? So feedback factor indicate that we doesn't apply all of the output here, right? Part of output is applied to the again input, right? So in this case, we have applied the sine wave, we got the cos wave. So part of that cos wave means cos wave signal, part signal should be applied to the input, right? So applied signal is sine wave and the feedback signal is cos wave. So they are, see, they are in out of phase. Out of phase indicate that we have applied the sine wave, we feedback as a cos wave, right? So they are out of phase. So if the input signal and output signal are in out of phase, in that case, that type of feedback is called as negative feedback. Normally, see, due to use of negative feedback, whatever the gain of your amplifier, that should be reduces, right? So gain should be reduces. It causes gain should be less, right? So it also it is used in case of your amplifier. The reason behind it is that, see, when we have to use the negative feedback amplifier, the gain of the amplifier is stabilized. Stabilizes indicate that if we have to use this amplifier for the 10 kilohertz frequency, only 10 kilohertz frequency is coming with respect to your output, not it should be varying with respect to 9 kilohertz or the 11 kilohertz, right? Means if we have to be use the amplifier for particular application, it must have required the particular frequency, right? For that purposes, we have to be use the particular type of the amplifier here, right? So that's why we have to be use the negative feedback for the application of your amplifier, right? See, did you understand the concept of the types of feedback, that is positive feedback and negative feedback? Please tell me. लक्षात आलाय? लक्षात आलाय? दळवे, अंकलगी, देवमारे सांगा, लक्षात आलाय का?
Yes, sir.
Okay. See, again, we have just something discusses with respect to positive and negative feedback of the amplifier. See, feedback indicate that we have to signal, whatever the signal applied across your input, that should be considered as a voltage or current. That is not important, because see, when we are discussing the amplifier, in that case, whatever the output comes, that must be normally current, or that might be voltage. Why it is? Because some application requirement of the more current and less voltage, some application require the more voltage, less current, right? So that we have to be considered as either your voltage or current. It is nothing but input, whatever the input applied across your amplifier, right? So in case of your positive feedback, we have apply their signal, that is applied a signal, and the whatever the output indicate that feedback, that signal are in phase. In that case, that type of feedback is called as a positive feedback. But when we have to use the positive feedback, in that case, whatever the gain coming, that is fluctuating, right? That's why it is not used for the some application. So that's why some of the application we have to use the direct feedback. Version type of the feedback is in case of your some of the amplifier. Due to use of the direct feedback, it doesn't reduces the gain of your amplifier, right? So if we have to be use the amplifier, in that case, we must apply the negative feedback, which causes it should reduces the gain of amplifier, but it stabilizes the gain, right? So in case of your amplifier, we must apply the negative feedback, right? In case of your oscillator indicate that the device which have the sine wave signal as output. In that case, we have to be use the positive feedback, right? So normally we discussing with respect to negative feedback. Negative feedback indicate that if the input, see, consider as a input applied to any of the amplifier is a sine wave, output coming across, it is a consider as a consider that we have to use the common emitter amplifier. See, output of common emitter amplifier is 180-degree phase shifted. So we have apply input as a sine wave, we got the output as a cross wave, right? So again that cross wave is applied to the input. It is nothing but a feedback, right? So input signal is sine wave, whatever the feedback coming is a cross wave. So both signal, means input signal and output signal, have 180-degree phase shift. So they are not in phase. It is also called out of phase. So if input signal and output signal are in out of phase, in that case that type of feedback is called as negative type of feedback. So this type of feedback is in case of your amplifier. See, due to the use of negative feedback, again I'm telling you, the gain of the amplifier should be reduced, but also it is used in case of amplifier. The reason behind it is that due to the use of negative feedback, there should be increase in the there should be decrease in the gain, but it should be stabilized, right? Stabilized. So any of the application, stability is important factor, because when it gives the more frequency, it is also not acceptable. It gives the less frequency, it is not applicable, not required, because it gives the proper required frequency. That's why we have to be use the negative feedback to stabilizing the gain of the your amplifier. Okay, did you understand the thing related to the positive negative feedback amplifier? Please tell me. याच्या रेस्पेक्ट टू लक्षात आलंय सगळ्यांच्या? प्लीज रिप्लाय द्या. लक्षात आलंय ना? कोकरे, मानेर सांगा, लक्षात आलंय ना? लक्षात आलंय का? नसेल तर परत एकदा सांगेल. लक्षात आलंय ना?
Yes, sir.
Okay. See, up to now we have seen the feedback and the feedback amplifier. See, there are no different topology used for the purpose of your feedback amplifier. See, what do you mean by topology? See, there are different application of your amplifier, right? So for that different application of amplifier, they have sometimes require more voltage, more current, somewhat input impedance more. So somewhat we have required the input as well as output impedance more or less. Accordingly, we have to be done the different type of the topology for the feedback purposes, right? According to that topology indicate that it is different type of the amplifier types, right? It is nothing but a topology, right? So accordingly, we have to use the different type of the topology, and that should be used, which causes we got the particular thing as we have required, right? So some of the topology means combination. See, topology indicate that basically whatever the feedback, see, in case of your feedback amplifier, we must use the thing related to the topology with respect to feedback, right? So sometimes whatever the feedback that should be coming in a series, means that should be coming in a shunt. Sometimes it is a voltage, so it is called as voltage series. Sometimes it is a current, so it is called as current series. Sometimes it is a in a voltage shunt, voltage series, current shunt, current series. That are the four type of the particular topology of your amplifier, right? Why that topology design? See, when we have, I am already told you regarding with it. See, when we have used the different application, it have requirement different, right? According to their requirement, we have to be design the particular type of the amplifier. For that purposes, we have to be use the different topology of the amplifier, right? Topology indicate that how the output part applied to the input. Accordingly, that topology divided, either it connected in a series, either it is connected in a parallel, either it is connected in a voltage series, either it is connected in a current series, right? Accordingly, there are different type of the particular feedback amplifier topology. See, initially we generalize discusses with respect to the types of feedback, right? Normally feedback topology, see, this is nothing but types of feedback topology, right? So we know that voltage and current, that all the things related to the voltage and current, either it is connected in a voltage. See, if we have to be connected voltage in a series, in that case that is called as voltage series feedback. When same it is connected in a parallel, then it is a voltage shunt feedback, right? So when current with respect to current, if it is connected in a series, then it is called as current series feedback. When current same connected in a parallelly, then it is called as current shunt feedback, right? So accordingly, see, both cases voltage and current term only used, but according to their combination, that is either series or the shunt indicate the parallel. According to their connection with respect to series and shunt, there are 4 types of the particular configuration. See, only 2 type is coming with respect to voltage and current, but how they connected, right? Either it is connected in a series or shunt. Accordingly, it have 4 types, right? See, voltage series feedback. See, we have seen the voltage series feedback. So what we have to do in this feedback? See, actually we know that feedback indicate that we have applied the signal, its output is coming. So part of output, see, part of output is again applied to the input with series. See, part of output applied to the input with series. In that case, that is called as voltage series feedback, right? So see, voltage series is nothing any other thing, right? It is basically voltage series feedback. It is a feedback amplifier, right? So feedback amplifier means indicate that part of output is again applied to the input. This is the basic thing. But voltage series indicate that if the part of output, see, if the part of output again applied to the input with series, right? With series, then that is called as voltage series feedback, right? So when we have to be use the voltage series feedback, in that case, if we have to be applied a signal causes reduced again, in that case we have to be use the voltage series feedback. Means when we have to be use the voltage series feedback, in that case whatever the gain coming across your amplifier, that should be reduced, right? So for that purposes we have to be use the voltage series feedback. Also, see, when we see, you know about the maximum power transfer theorem, please tell me. That is electrical important part, maximum power transfer theorem. Please tell me anyone. Did you have know about the maximum power transfer theorem? This is important for this discussion. Tell me. Maximum power transfer theorem. When does the maximum power transfer from your source to the destination? Please tell me. Did you know about the maximum power transfer theorem? माने मॅक्सिमम पॉवर ट्रान्सफर थेरम झाली का तुम्हाला? देवमारे दळवे झालेले असेल बहुतेक. झाली का? सगळ्यांसाठी सेमच आहे, म्हणजे ते इलेक्ट्रॉनिक्स मध्ये जावा नाही तर अदर कुठले मॅक्सिमम पॉवर ट्रान्सफर थेरम सेमच असते. झाली का? येस और नो सांगा.
No, sir.
Okay, I'm telling you. See, what do you mean by maximum power transfer theorem? See, when the source impedance equal to the load impedance, then maximum power transfer from your source to the load. This is the concept of maximum power transfer theorem. परत सांगतो, लक्षात घ्या. सो तुमची मॅक्झिमम पॉवर ट्रान्सफर कधीही एका सोर्स करून दुसऱ्या डिव्हाइसकडे कधी होते, जर तुमचा सोर्सचा इम्पिडन्स म्हणजेच रेजिस्टन्स कन्सिडर करा. सोर्सचा रेजिस्टन्स बरोबर तेवढाच तुमच्या लोडचा जर इम्पिडन्स असेल ना, तिथून मॅक्झिमम पॉवर ट्रान्सफर थेरम होत, जे तिथून मॅक्झिमम पॉवर ट्रान्सफर होत असतं. लक्षात घ्या. मीन्स सोर्स इम्पिडन्स इक्वल टू लोड इम्पिडन्स. दिस इज द कन्सेप्ट ऑफ युअर maximum power transfer theorem. Same thing. See, if we have to be used the amplifier for any of the application, right? So if we have to be used the amplifier for any of the application, in that case, see, we have actually use of amplifier. The reason when it is we have required the more strength signal, right? So that's why whatever the output coming, see, we know that whatever the output coming from your amplifier, that should be applied to the speaker, right? That should be applied to the speaker. In that case, if the consider the gain of amplifier is 1 kilo ohm, right? Gain of the amplifier is 1 kilo ohm, and the your speaker gain is 10 kilo ohm. Is there maximum power transfer theorem? Please tell me. म्हणजे amplifier ची गेन 1 किलो ओम आहे आणि तुमच्या स्पीकरची गेन 10 किलो ओम आहे, त्याच्यात मॅक्सिमम पॉवर ट्रान्सफर होईल का? सांगा. आताच तुम्हाला मॅक्सिमम पॉवर ट्रान्सफर थेरम सांगितलंय, सांगा होईल का? प्लीज रिप्लाय द्या. होईल का नाही? येस और नो?
No.
Right. See, why not it is happen? See, I am already told you related to the maximum power transfer theorem when the source impedance equal to the load impedance. Now see, I'm telling you source impedance of the particular amplifier is 1K, right? For the speaker, it is a 10K. That is different term, right? 1K, 10K, that is different. So that there should not be possible of maximum power transfer theorem. म्हणजे जो amplifierचा concept आहे, म्हणजे मी जस्ट सिग्नल कमी आवाजात माईक मध्ये बोललो, ते अँप्लिफायरला मिळाले, त्याने अँप्लिफाय केली, बरोबर. इथपर्यंत सगळं व्यवस्थित झालं. पण पुढे जो लाऊडस्पीकर कनेक्ट केला ना, त्याचा इम्पिडन्स खूप लार्ज आहे, लक्षात घ्या. त्यामुळे तिथून मॅक्सिमम पॉवर ट्रान्सफर होणार नाही. त्यामुळे जेवढं अँप्लिफिकेशन जरी मिळलं तुमच्या अँप्लिफायरला, तर तेवढ्या स्टेज मध्ये तुमचे सिग्नल पुढे जाणार नाही, हे लक्षात घ्या, राईट. So that's why we have to be use the condition of the impedance, right? So in case of your voltage series feedback, I'm telling you the concept of the particular thing. See, in case of your voltage series feedback, it reduces the output impedance, right? See, if we have to be use the device, see, after all amplifier is used here, right? So whatever the device, see, whatever the device connected across speaker, it have consider as a, see, 10K, and here is the 1K, right? So now we have taking the second another example, right? It reduces indicate that if see whatever the output impedance coming from your amplifier is 1K, right? So it should be connected to the speaker, right? When it is a reduction, it's whatever the impedance, if it is reduces, means when we have to be use the voltage series feedback, in that case it reduces, right? So it reduces indicate that if it is coming to the 2K, right? When we have to be use the voltage series feedback, and that is it is coming to the 1K, so there should be chances of the power transfer when it is a 10K, right? 1K असताना म्हणजे तुमच्या अँप्लिफायरचा इम्पिडन्स 1K आहे आणि याचा त्यावेळेस 10K होता, त्यावेळेस पॉवर ट्रान्सफर कमीत कमी होत होती, पण तो कमी झाला आता रिड्यूस झाल्यामुळे. कारण का, मी व्होल्टेज सिरीज फीडबॅक यूज केला, लक्षात घ्या. त्यामुळे रिड्यूस झाला, त्यामुळे काय होणार आहे, कम्पेअर टू द 10K त्याच्यात नॉर्मलाइज ग्रेटर पॉवर ट्रान्सफर होईल, लक्षात घ्या. ओके, सो in this case we discussed it reduces when we have to use the voltage series feedback, it reduces the output impedance of the particular thing, right? So it reduces the output impedance and increases the input resistance, right? So when we have to use the voltage series feedback, it causes whatever the output impedance of your circuit that should be reduces, and the whatever the input impedance of your particular configuration that should be increases, right? This should be happen when we have to use the voltage series feedback. So see, when we have to be requirement of the reduction in the output impedance and the increase in the input impedance, in that case we have to use the voltage series feedback. Okay, now see, voltage shunt feedback. Voltage shunt feedback is nothing but it is the feedback which should be applied for your, see, whatever the, see, we have discussing with respect to feedback amplifier. So we have applied the signal, that is a voltage signal, right, applied to the output of particular amplifier, right? Output of it is nothing but a voltage, right? So if the voltage of the means output of your amplifier again applied to the input of your amplifier in a shunt, indicate that parallel to the input, right? In that case, that type of amplifier is called as voltage shunt type of the feedback amplifier, right? So in case of voltage shunt feedback, see, we have applied the signal, that is a voltage signal, output coming, it is also the voltage signal. So part of its output voltage is again applied to the input with a shunt, with shunt indicate that parallelly, right? Output of it is again applied to the input with a parallelly. In that case, that type of feedback is called as voltage shunt type of feedback. When we have to be use the voltage shunt type of feedback, it stabilize the gain, right? Means when we have to be requirement of the stabilized gain indicate that the gain should not be varying with respect to time, right? In that case, we have to be use the voltage shunt type of the feedback in case of your amplifier configuration, right? Means I'm already told you related to the stabilization of the frequency, because see, each and every application, if the gain is varying with respect to time, this is not acceptable. जुने जे अँप्लिफायर असायचे ना, म्हणजे फंक्शन मध्ये वगैरे यूज केल्याचे, त्याचा आवाज कमी जास्त वगैरे व्हायचा जुने, म्हणजे एक 15-20 वर्षापूर्वी जे अँप्लिफायर यूज केले जात होते, म्हणजे तर त्याच्यात काय होत होतं, स्टॅबिलिटी हा कन्सेप्ट नव्हता, म्हणजे गेन सारखी, म्हणजे आवाज कमी जास्त वगैरे वगैरे होत होता. पण आता there should be tremendous development in electronics as well as the amplifier technology. So that's why there should be correction technique used for that. And now whatever the amplifier is, they doesn't happen that type of the things, right? So see, we are discussing with respect to the voltage shut. So when we have to be use the voltage type of feedback, it stabilize the overall gain, right? So stabilize the gain as well as input and output impedance also reduces. Means where we have to be requirement of the reduction of the input as well as output impedance. In that case, we have to be use the voltage feedback as well as it stabilizes the gain, right? So voltage feedback amplifier for that application. Now see current series feedback. Current series feedback, what it does? See, current series feedback is nothing but we have apply the voltage. See, we have apply the voltage which should be develop the proportional current, right? In case of your current series feedback, we doesn't apply current. I'm telling you, doesn't apply the current. But when we have applied the voltage in accordance with we have to be generate the current in accordance with whatever the voltage applied. So we have to be generate the current, means in proportional to the applied voltage it generates the current. So this current used for the purpose, this current used as a feedback, right? So this current is subtracted from the input voltage. How it is? See, part of it is again applied to the input, right? So that's why it is subtracted from the input voltage, right? So see, why it is subtracted from input voltage? See, whatever the input applied, that is voltage. See, whatever the applied signal across your current series feedback, in case of your current series feedback, we actually apply the voltage. See, in case of your current series feedback, we doesn't apply the current. See, we have applied the current, we have applied the voltage in proportional to that. See, in proportional to that, we have generated the current, right? So that's why in current series feedback, we have applied the voltage in accordance with proportional particular current is generated. So in case of your input, it is basically voltage, right? कारण व्होल्टेज जरी अप्लाय केले असलं तर त्याच्या रिस्पेक्ट टू पुढे जाऊन तो करंट त्याच्या प्रोपोर्शनल होतोय, पण इनपुट व्होल्टेज राहतं, लक्षात घ्या. सो व्हेन इट इज अगेन अप्लाय टू द इनपुट, राईट? सो व्हेन इट इज अगेन अप्लाय टू द input as a feedback, in that case it should be subtracted from the input voltage, right? So it is subtracted from the input voltage. Why? Because applied signal is voltage. When it is going to the current series feedback, in that case it should be act as a current, right? That current output of coming is a current, so again it is applied to the input feedback. So it is nothing but whatever the input is voltage, so it should be subtracted from the voltage. Why it is? Because whatever the output coming, that is a current, right? So when we have to be use the series type of the connection, in that case input and output impedance increases. Why? Because see, we have applied the voltage, we got the output thing as a current. And see why it is? Because in current series feedback, we have applied thing as a voltage, we got output proportional to the current. Say again that current is applied to the input, so in that case whatever the voltage applied, accordingly current got, that is a negative feedback. See, current got, that is a negative feedback. That's why that should be subtracted from your whatever the input voltage applied, right? So that's why what happened, it causes, so that's why it causes whatever the input impedance and whatever the output impedance, that should be increases. Why it is increases? See, due to the application of this voltage and coming from your output as a current, it due to that it cause, because of that there should be increase in the input impedance as well as output impedance. That's why that value should be increased. So this type of the, so increase in the resistance, that's why this type of the amplifier is called as transconductance. Transconductance indicate that increase in the impedance, right? So see, this is the thing with respect to current series feedback. Last type we have seen that current shunt feedback. Now see, whatever the thing, voltage series, voltage shunt, current series, current shunt, only thing is that how the output is connected to the input, that is nothing but a particular type of feedback, right? So in with respect to your current shunt feedback, whatever the, see, we have applied the signal. That signal is coming across your output. Again, that signal is again applied to the input, right? So that signal is applied to the input with shunt. Shunt indicate that parallel to the input. So in current shunt feedback, we have applied the signal. That signal must be in shunt with input. That's why it is called as current shunt type of the feedback, right? Though see, this type of connection causes input reduces the means input as well as input as well as the changes on the output impedance, right? Why it is? Because see, when we have to use the current series feedback, when it is coming to the output, see, when we have applied the input as a current, see, we have applied as a current, it should be converted into the voltage, see, because shunt, it should be applied with the input as a voltage. So when it is applied in parallel indicate that it is a voltage. See, I'm telling you, current is connected, current is applied to the any of the circuit, or current we have seen in a series, and voltage must be seen in a parallel. That's why in case of current series feedback, we have applied the input in a applied input as a current, and again it should be applied in a shunt to indicate that it is a parallel, so it is converted as a voltage. So in that case, whatever the due to that reason, whatever the resistance of the devices, that should be reduces, right? And this causes what, see, there should be reduction in input resistance as well as there should be increase in the output impedance. Why it is happen? See, when we have to be use the current series current shunt feedback, when we have to be use the current shunt feedback, see, it applied a thing is current, right? We got output as a voltage. Why it is voltage? Because whatever the part connected across your feedback, that is a voltage, or it is in a shunt indicate that parallel. So parallel connected is nothing but a voltage, right? So that to convert it as a voltage, in that case, when it is used in a series, means current is nothing but a series, and when output is nothing but a shunt, in that case changes with respect to your input as well as output impedance. So due to that configuration, there should be reduction in the input impedance, and at the same time there should be increase in the output impedance, because when we have to be use the applied the current and we got the voltage, in that case this thing happen, means it increases the it reduces the input impedance and it causes increases the output impedance. Okay. Yes, sir. Okay. We discusses the four type of feedback in detail. Before saying that, any of the thing म्हणजे आतापर्यंत जे झालेलं आहे यापैकी कुठलं लक्षात आलं असेल तर मला सांगा, ते रिपीट करून आपण त्यानंतर पुढच्या फीडबॅकचे टाइप आहेत, म्हणजे हे जे आहेत व्होल्टेज सिरीज, व्होल्टेज शंट, करंट सिरीज आणि करंट शंट पाहूया. सांगा याच्या रिस्पेक्ट आतापर्यंत जे झालंय त्यापैकी कुठला पार्ट लक्षात आला नाही. त्यानंतर आपण इकडे जाऊया. प्लीज टेल मी, आतापर्यंत ज्या काही स्लाइड झाल्या त्यापैकी कुठला पार्ट लक्षात आला नाही मला सांगा. नसेल तर आपण पुढे जाऊया. प्लीज टेल मी, पुढचा पार्ट सुरू करू. हे याच्यावरून तुम्हाला ऍक्च्युअल थिंग म्हणजे मी जे आता सांगितलं ना थेरॉटिकली, ऍक्च्युअली कसं होतं हे लक्षात येईल, डायग्राम जर काढली तर लक्षात घ्या. ओके, पुढचा पार्ट सुरू करू का? याच्यावरून मी काय करतो, हे तिन्ही म्हणजे पुढचे पार्ट सांगतो, त्यानंतर जर लक्षात आलं नाही तर आपण रिपीट करू, चालेल? कारण या डायग्राम म्हणून तुम्हाला जे मी आता थेरॉटिकली जे सांगितलं ना सगळं, ते या डायग्राम म्हणून चांगलं लक्षात येईल. आता जे आपण डिटेलमध्ये व्होल्टेज सिरीज फीडबॅकचं, व्होल्टेज शंट किंवा पुढच्या फीडबॅकचं पाहतोय, या डायग्राम म्हणून तुम्हाला डिटेल लक्षात येईल. ओके, चालेल? परत इकडलं कुठला पार्ट? माने, कोकरे सांगा. पोद्दार, हे सांगू की हे समजलं नाही कुठलं सांगा का हे सांगून त्यानंतर आपण पाहायचं सांगा लवकर. व्होल्टेज सिरीज फीडबॅक ओके. आपण हे काय करू आधी हे चारही फीडबॅक पाहू डायग्राम्स आहेत त्यानंतर जर नाही कळलं तर आपण ते रिपीट करू. ओके ओके we know that we have to be seen the four type of the feedback topology, right? Voltage series, voltage shunt, current series and current shunt. How it is defined or how it is differentiated with respect to particular thing that should be explained by this diagram. See the diagram. We have seen that now हे सांगायच्या आधी सगळं सांगतो आपण हे सगळे फीडबॅक जे चार टाईपचे पाहिलेत ना हे कुठे यूज केले जातात तर सांगतो. समजा आपण एक्झाम्पल घेऊया चार टाईपचे फीडबॅक आहेत लक्षात घ्या जिथं आपल्याला सांगितलं इनपुट इम्पिडन्स आउटपुट. जर तुम्ही तुमच्या अँप्लिफायरला जर अशी डिव्हाइस यूज करताय की ज्याचा इनपुट इम्पिडन्स कमी आहे आणि आउटपुट इम्पिडन्स सुद्धा कमी आहे त्या ठिकाणी तुम्ही पर्टिक्युलर म्हणजे अकॉर्डिंग टू कंडिशन पहा इथं आता पहिलं जे आहे व्होल्टेज सिरीज फीडबॅक याचे थिंग काय इट रिड्युसेस द आउटपुट इम्पिडन्स आणि इन्क्रीजेस द इनपुट इम्पिडन्स राईट. जर जिथला आपला इम्पिडन्स रिड्युस्ड असेल लक्षात घ्या म्हणजे सॉरी आउटपुट इम्पिडन्स रिड्युस्ड असेल इनपुट इम्पिडन्स जास्त असेल अशा ठिकाणी आपण व्होल्टेज सिरीज फीडबॅक म्हणजे त्या ठिकाणी म्हणजे सांगतो तुमचा अँप्लिफायर आहे ना त्याच्या पुढे तुम्ही जो स्पीकर यूज करणार आहात लक्षात घ्या त्याच्यावर त्याचा जर इम्पिडन्स जर समजा तुमच्या अँप्लिफायरचा इम्पिडन्स जो आहे पहा तो इम्पिडन्स जो आहे तो कमी असेल आणि तुमच्या डिव्हाइस जो आहे त्याचा इनपुट इम्पिडन्स जास्त असेल राईट. या ठिकाणी तुम्ही व्होल्टेज सिरीज फीडबॅक नाही यूज करणार. लक्षात घ्या मी परत एकदा सांगतोय की पहिल्यांदा लक्षात घ्या ज्याचा इनपुट इम्पिडन्स लक्षात घ्या इट रिड्युसेस द आउटपुट इम्पिडन्स म्हणजे आउटपुट इम्पिडन्स कमी आहे लक्षात घ्या म्हणजे 1K समजा तुमचा आउटपुट इम्पिडन्स आहे आणि तुम्ही डिव्हाइस जे कनेक्ट करताय त्याचा समजा 10K आहे लक्षात घ्या. या केसमध्ये म्हणजे पर्टिक्युलर त्याचं जे आउटपुट आहे म्हणजे आउटपुट इम्पिडन्स आणि इनपुट इम्पिडन्स यांना काय होतंय जर मी व्होल्टेज सिरीज फीडबॅक यूज केला तर आउटपुट इम्पिडन्स वाढतोय आणि इनपुट इम्पिडन्स कमी होतोय राईट. म्हणजे हे तुम्ही तुमच्या डिव्हाइसचा आउटपुट इम्पिडन्स किती आहे आणि तुम्ही स्पीकर यूज करताय त्याचा इनपुट इम्पिडन्स किती आहे यानुसार तुम्ही पर्टिक्युलर कॉन्फिगरेशन यूज करणार आहात. लक्षात घ्या जर तुमच्या डिव्हाइसचा आउटपुट इम्पिडन्स जर कमी असेल आणि इनपुट इम्पिडन्स जास्त असेल तर त्या केसेसमध्ये तुम्ही व्होल्टेज सिरीज फीडबॅक यूज करणार. त्यानुसार त्याची प्रत्येकाची पर्टिक्युलर थिंग म्हणजे आउटपुट कसं आहे त्याच्यानुसार आपण पर्टिक्युलर कॉन्फिगरेशन यूज करणार आहोत. ओके सी व्होल्टेज सिरीज फीडबॅक. सी this is the diagram of the amplifier, right? So this is nothing but a input. See, input is applied to the operational amplifier. Operational amplifier indicate that amplifier, right? So this is the input which should be applied to the input of your amplifier, right? So this input is applied, so we got the output, right? We got the output across your output, right? So voltage series indicate that we have applied the voltage. See, we have applied the voltage, right? So we have applied the voltage. So voltage series indicate that whatever the output coming, see whatever the output coming, that is the voltage output, right? Voltage output because the feedback name is voltage series. So output is voltage. So voltage indicate that voltage. लक्षात घ्या कसं कनेक्ट केलं जातं सिरीज मध्ये की पॅरलल मध्ये. प्लीज टेल मी कशामध्ये पॅरलल. right. So voltage series indicate that whatever the output coming that is parallel. कारण का की व्होल्टेज आहे लक्षात घ्या व्होल्टेज तुमचा आउटपुट आहे म्हणजे त्यामुळे ते पॅरलल असेल. सिरीज इंडिकेट दॅट पहा हे जे व्होल्टेजचा फीडबॅक आहे ना तो तुमच्या इनपुटला कनेक्ट करत असताना सिरीज मध्ये घेतलाय. पहा सिरीजली कनेक्ट केलाय. पहा सिरीजली कनेक्ट केलाय त्यामुळे याला म्हटलं जातं पहा सिरीजनी त्याची तुमच्या डिव्हाइसला कनेक्ट केलेला आहे कारण त्याचा एकच पार्ट याला कनेक्ट केलेला आहे म्हणजेच सिरीज झालेला आहे. म्हणजे व्होल्टेज सिरीज फीडबॅक काय असतं ज्यावेळेस आपण इनपुट अप्लाय करतो इनपुट अप्लाय केल्यानंतर आउटपुट जे जनरेट होतं ते आउटपुट जनरेट झालेलं असतं ते व्होल्टेज सिरीज इंडिकेट काय असतं सम पार्ट ऑफ व्होल्टेज ऑफ द amplifier is again applied to the input with series, right? So voltage indicate that it should be connected in a parallel, right? It should be connected in a parallel. Again, this is nothing but a voltage, right? So it should be connected with respect to the amplifier in a series. So see, it should be connected in a amplifier in a series. So it is nothing but a voltage series type of filter, feedback. म्हणजे व्होल्टेज सिरीज फीडबॅक म्हणजेच काय असतं, तुमच्या अँप्लिफायरचं जे आउटपुट आहे ते आउटपुट ऍज अ व्होल्टेज आहे, ते व्होल्टेज आउटपुट तुम्ही तुमच्या अँप्लिफायरला इन सिरीज मध्ये जर कनेक्ट करत असाल तर त्याला व्होल्टेज सिरीज फीडबॅक असं म्हणायचं. ओके, सो फीडबॅक इंडिकेट दॅट part of it, so part of it is nothing but a feedback or feedback factor, right? लक्षात घ्या, जर इथं समजा सिग्नल अप्लाय केलेली आल्यानंतर आउटपुट 10 असेल तर त्याचा काही पार्ट म्हणजे समजा 2 or 5 only apply to the here, that's why it is called as sometimes feedback or feedback factor, right? Apply to it. So feedback factor applied to the input in case of voltage series feedback in series, right? That's why it is called as voltage series type of the feedback, right? So now we discussing the what do you mean by voltage series feedback. So in this type of the circuit, a portion of the output voltage can be applied to the input voltage in series, right? In series means portion of the output is again applied to the input in a series. That's why it is called as voltage series type of the feedback, right? So means what? Voltage indicate that actually it is a series feedback, right? So whatever the thing connected, it means output thing also connected here also in series. लक्षात घ्या, पण लक्षात घ्या तुम्हाला व्होल्टेज कधी सिरीज मध्ये नसतात, लक्षात घ्या ते इन पॅरलल असतात. त्यामुळे हे ज्या थिंग याला जोडतोय आपण त्या व्होल्टेज थिंग जोडतोय, जरी सिरीजली कनेक्टेड असल्या तरी त्यासाठी काय करतोय आपण, ह्या कनेक्टेड पॅरलली करतोय. व्होल्टेज असल्यामुळे ह्या थिंग तुम्ही पॅरलली कनेक्ट करताय आणि या डिव्हाइसला जोडत असताना पहा, या डिव्हाइसला जोडत असताना त्या सिरीज मध्ये जोडतोय. सिरीज इंडिकेट दॅट पहा, हे जे इनपुट आहे ना, इनपुटला सिरीज मध्ये जोडतोय, सिरीज मध्ये. त्यामुळे याला व्होल्टेज सिरीज फीडबॅक असं म्हणायचं असतं, लक्षात घ्या. आणि नॉर्मली हे कॉन्फिगरेशन जर यूज केलं ना तर याच्यामुळे इनपुट इम्पिडन्स रिड्यूस होतो आणि आउटपुट इम्पिडन्स वाढतो, लक्षात घ्या. जर आपण व्होल्टेज सिरीज फीडबॅक म्हणजे जिथं आपल्याला नीड असते की तुमचा रिडक्शन इन output impedance and increase in the output, in that case we have to use the voltage series type of feedback, right? तर हे जे कॉन्फिगरेशन आहेत चारही पाहणार आहोत आपण हे अकॉर्डिंग टू आवर नीड. ओके, अटेंडन्स द्या. रोल नंबर 1
Present, sir.
2
Present, sir.
3
Present, sir.
4
Present, sir.
5
Present, sir.
6 7 8 9 10 11
Yes, sir.
12
Present, sir.
13
Present, sir.
14 15
Yes, sir.
16
Present, sir.
17 18
Yes, sir.
19
Yes, sir.
20
Yes, sir.
21
Yes, sir.
22
Present, sir.
23 24 25
Present, sir.
26 27 28 29
Present, sir.
30 31
Yes, sir.
32 33 34 35 36
Yes, sir.
37
Yes, sir.
38
Present, sir.
39 40 41 42
Yes, sir.
43 44 option number 6 7
Sir,
8 9.
6 present.
Okay, 6 7 sorry 7 8 9 10 13 14 17 23 24 26 27 28 30 33 34 35 39 40 42 43 44. हा सांगा.
30 present.
30
Present.
30 प्रेझेंट. ओके, अजून
13 present, sir.
ओके, आणखीन
26.
26. ओके, आणखीन ओके, स्टॉप करूया आपण.